Hello, we are in Chapter 5, Section 5.8, the Pythagorean Theorem and the distance and midpoint formulas. In this video, we're going to learn about the distance and midpoint formulas. So let's look at 2 points on the coordinate plane randomly placed, and we want to first examine the distance between those 2 points, which is pretty much the length of the line segment joining them. Let's label it D. We can always complete this picture to a right triangle and acknowledge that the other vertex of the triangle at the right angle has the same x-coordinate as the first point and y-coordinate as the second point. Now, the distance on the real number line is measured by the absolute value of the difference of the two numbers. And along the horizontal line between the new point and the second of our original points and the vertical line between the new point and our first original point are just real number lines. So, because on that horizontal line the y-coordinates are the same, the length of that bottom side of our triangle is simply equal to the absolute value of the difference between the x-coordinates of those endpoints of this line segment of this side. Similarly, for our left side, we are on a vertical line where all the x-coordinates are the same, so the length of this segment is measured by the absolute value of the difference of the y-coordinates of the endpoints. Now recall that the Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the lengths of the legs and c is the length of the hypotenuse. So if we use our labels in here, we get the following equality that we solve for d by taking the left-hand side and square rooting it, because we need the positive outcome since d is the distance. Notice that we also remove the absolute values, since squaring takes care of making things positive. And this is the distance formula. Let's turn our attention now to the midpoint formula. That means the coordinates of the midpoint of the line segment joining our two original points. Notice that if we drop the vertical line down to that bottom leg of our triangle, we acknowledge that the horizontal distance between x1 and x2 is divided by 2 to get the x-coordinate of that midpoint M. Similarly, if we draw the horizontal line to the left leg of our triangle, we also acknowledge that the y-coordinate of the midpoint is simply right in the middle between the y-coordinates of the original points. And right in the middle is the average, and the average is computed by taking the sum and dividing by 2. This is why the x-coordinate of the midpoint is the sum of the x-coordinates of the original points divided by 2, and the y-coordinate of the midpoint is the sum of the y-coordinates of the original points divided by 2. And that is the midpoint formula.